As usual, let's start off trying to estimate a very approximate answer before we start to get into the details. Perhaps the easiest way to estimate it here is to note, just think of a column of air. So let's take 1 square metre of the Earth's surface and take the column of air going all the way up to the top of the atmosphere, some height there. Now, why doesn't that column of air fall down? It's going to have a weight. The weight of that's going to be, let's assume that it's the same density all the way up. That's a good basic approximation. So in that case, the mass of that column is going to be the density of air times the cross-sectional area times the height. So density is just density times the volume. So the force downwards is going to be that times g. And that's going to be balanced by an upward force, so the air doesn't collapse. The upward force is going to be coming from the pressure at the bottom. So it's just going to be equal to the pressure at the bottom times the area. So cross-sectional area cancels out, and we find that the pressure at the Earth's surface is just what is required to support the weight of all the air above you, which is the weight of all the air above you per unit area times g. Now we know the pressure at the Earth's surface. Pressure at the Earth's surface is about 100,000 pascals, very large. So that's got to be equal to the density of air, which is around 1, times the height, times g, which is around 10. So that means the height is going to be roughly 10,000 meters, so about 10 kilometers. Quick order of magnitude estimate. Is that looking plausible? Well, I know that the normal definition of space is something more like 50 kilometers up, and in fact there's even a little bit of atmosphere where the space station is 800 kilometers up, so there's clearly some air more than 10 kilometers up, but our approximation here that the density is the same is a ridiculous approximation. It's not going to have a firm upper edge, it's going to get thinner and thinner and thinner. But on the other hand, we know that at the top of Mount Everest, and you're 8 kilometers up, the atmosphere is pretty much too thin to breathe unless you're some superhuman mountain climber. So 10 kilometers is probably about right. It's clear the atmosphere at 10 kilometers up is a way thinner than the Earth's surface. So that's a sort of sensible scale length for the atmosphere.